Hi, my name is Ned Twigg, and I work for DiffPlug. We have a graphical Git client, which is built on top of Eclipse RCP. It lets you drag commits around to do rebases and merges and multi-select to do squashes, things like that. Check it out if you're looking for a Git client. This talk is about integrating Gradle and Eclipse. There's a couple audiences for this talk. One of them is people who are building applications on top of Eclipse RCP. Another audience is people who are building Eclipse plugins. But this is also useful to people who are just building regular old jars that want to pull artifacts out of P2 repositories, or people who would like to build their IDE as a build artifact for a repeatable developer experience. So because this talk has a lot of audiences, I'm going to just define some terms real quick. So we all know what a jar is, just a zip file full of class files. An OSGi bundle is a jar with export package and import package metadata embedded in the manifest. And this allows OSGi bundles to specify their dependencies in terms of packages versus the Maven model where you specify your dependencies in terms of identity on a specific jar. P2 is a repository format as well as a transport agent. So the way that a Maven repository holds jars, a P2 repository holds OSGi bundles. P2 can also do some other things. Like it can create native launchers, and we'll talk about some of the things it can do. Eclipse is the popular IDE platform, and then RCP is the infrastructure underlying that IDE. So you can build a lot more besides just IDEs on Eclipse RCP. You can build medical record systems or any kind of big heavyweight desktop application. So the outline of the talk, we're going to talk about why Gradle and why it's so great. Right now, it seems like Gradle has very low penetration within the Eclipse world, and that's too bad because Gradle has a lot to offer. Then we're going to talk about part of why that might be. P2 is very difficult to do in Gradle right now. And then we'll talk about the workarounds, ways that you can make P2 look like Maven to Gradle. And then we'll talk about ways you can use Gradle to make Maven look like P2 for Eclipse for the purpose of building Eclipse plugins. We'll use PDE Build to tie all this together. And then lastly, we'll put a cherry on top and use something called the OOMP project to create the IDE repeatably as a build artifact in your build. But first, let's look at a real quick demo. So in this demo, we're just making a plain old jar. It's real simple. And that jar happens to be a Gradle plugin. So we have a Gradle plugin called Spotless. It can do standard code formatting things like apply a license header, enforce trailing white space or indent with tabs. You can also use the code formatter from inside of Eclipse to format your white space and white space around parentheses, things like that. So in order to build this, we need to get the Eclipse JDT dependencies. So the build file for this looks like this. So here we have some Eclipse jars that we'd like in our project, which are not available in Maven. So from time to time, so Eclipse publishes its artifacts to these P2 repositories they call them update sites. They don't publish to Maven. And from time to time, people will pick up the mantle of taking Eclipse artifacts and putting them in Maven, but nobody has done that consistently over time. If you want the latest and greatest, you're going to have to get them from P2. So what this plugin does is it lets you add this Eclipse update site as a repository, and then add each of these jars as a dependency, and then it'll, using the real P2, download these artifacts and stuff them into a Maven repository on your local computer. And we're going to dig into the details of these a little later. The other thing this has is this little nugget here, the OOMP IDE plugin. So like before, we specify repositories where we'd like to download our IDE from. And there's a lot of local caching that happens, so it's very fast. So we want the 4.5.2 version of Eclipse. We want the latest buildscript plugin. We want, and as far as features in the IDE that we generate, we want to have the IDE platform, we want JDT, we want buildscript. When we run Gradle IDE, we will end up with a folder. It's about a megabyte for the whole IDE. And we achieve this through bundle pooling. So you can have, there's a cache folder that contains the jars, all the jars that Eclipse needs, and then we generate launchers for each project that reference those jars. So each IDE is totally isolated with its own settings and configuration and all of that. And it's very efficient in disk and in time generating them. So that was kind of quick. Now we're going to dig into more of the meat of why, of how to make this work and why we want to. So Maven right now kind of rules the Eclipse world, especially Tycho. The reason to use Gradle instead of Ant and Maven is that there is no barrier to seeding new automation. There's no fixed cost. So there's you can write a Maven plugin to do anything. The difference is in Gradle, you don't need to write a plugin. You can write just a couple lines that organically grow to be 10, 20, 30, until eventually it's kind of unwieldy, and then you refactor it out into a plugin. It's a very organic process. You end up automating tons of stuff that you wouldn't have otherwise. And there are other build systems out there that are based on scripting languages like Scons, CMake, Batch Shell, yada yada. The advantage of Gradle compared to them is that you've got the whole JVM ecosystem at your fingertips, and it's write once, run anywhere-ish. It's worked pretty good for us. We develop on Windows, Mac, and Linux, and it's served us really well. Once we started using Gradle to build our Eclipse RCP application, we started using Gradle to automate all kinds of things. So we have a TeamCity, Artifactory, Gitblit instances that we run our company on. And we have a Gradle script that brings that up. We have a script for distributing VPN credentials. We've got an OSGi or obfuscator. We just showed you Spotless, our code formatting enforcement plugin. And then we've also got Goomph. And that's what the rest of this talk is going to be about, Goomph. And Goomph is a collection of plugins and tasks which are useful for working with SWT, P2, and the RCP platform in general. So another quick demo. So the point of this demo is to show you that Gradle is production ready and the number of things you can automate. So like on our website, we've got this changelog thing, and we've got these documentation. On our CI server, if I click this deploy release button here, then it'll build and test the new application, upload the installers, upload new docs, update the news, email our customers, fully automated with just one button. We can also, with one button, deploy a beta version to select customers with auto update. So we've had cases where a customer wanted a feature, and we could that day iterate back and forth with them to make sure that we met their need very quickly. And Gradle makes it so easy to automate these things. I just really think you're missing out if you're not taking advantage of it. So one of the things that I think a lot of people miss is some of the, you lose by turning P2 into Maven, or by pretending that P2 is Maven, you lose some things. So I just want to real quick make sure people understand, a lot of times people say P2 is so complicated. Why is it so complicated? There's a good reason. There's some features that it has that Maven doesn't. I want to make sure we understand those. So here we've got some code that relies on Guava 18, needs Guava 18 to run. And here we have some other code that relies on Guava 17 to run. And here we've got some code that needs both Guava 17 and 18 in order to run. It depends on both of these libraries. Importantly, it doesn't depend on Guava 17 or 18 directly. It just depends on code that uses them. So in the Maven world, if I ask for that bottom box, then I will get both of its dependent libraries, and I'll only get Guava 18. I won't get Guava 17 because there's no way to have Guava 17 and 18 at the same time. And so this is called a conflict diamond. If you ran this code, if you use Maven to download your dependencies and then ran this code, you would get a class not found or method not found error because you have this conflict around which version of Guava to have. So one of the things that OSGi lets you do is to have two versions of the same library at the same time. So OSGi metadata specifies all the packages that a jar provides to the runtime and all the packages it requires from the runtime in order to run, in order to provide those packages. Looking at this metadata, importantly, if you look at Guava 18, you'll see that it supplies the package needs 18, and it needs this Guava package 18, but it doesn't export that Guava 18 package. That Guava dependency is encapsulated entirely inside of that jar, and it's the same for Guava 17. So the code that exports package needs 17, it needs Guava 17 internally, but it doesn't export it. And that means that for this bottom dependency, which needs package 17 and 18, the Guava conflict is invisible to it. It can't see it. And so the OSGi runtime is able to put Guava 17 and 18 on the class path at the same time and make sure that the code that needs Guava 18 gets it, the code that needs Guava 17 gets that, and everything just works out very nicely. So as a consequence of this, when P2 does dependency resolution, it does it on a per package basis. So when you tell P2 that I want this jar, it's going to look and say, what are the packages this jar needs? And then it'll look in the universe of all the jars it knows about to see who else provides those packages to decide, and then what packages do they need and they need. So it's a much more complex process than what the Maven dependency model uses. What this means is that in Maven, repositories tend to be monolithic, where you just have Maven Central and you get whatever you want from there. In the P2 world, you usually have per project and even per version repositories to limit the universe of places to look for dependencies. So, for example, there is no download.eclipse.org repository. There is a repository specific to 4.5, and then that happens to be a composite of other versions. So if you look inside of this URL, you'll see that there's a release 4.5 and then a service release 1, service release 2. And then inside of those folders, you have the concrete P2 repository and its artifacts. So now that we've talked about what P2 can do, and especially the things P2 can do that Maven can't, we can start to unpack the problem of how do we use P2 in a Maven environment. So right now, there's no native support from Gradle. David Akehurst has a P2 resolver plugin, which is close. It requires a Gradle version less than 2.8. He also has, so that's pretty old. Gradle's gotten a lot better since 2.8. He also has a fork of Gradle 2.13, which has P2 support embedded right inside it. I don't think Gradle is going to merge that, probably. So until Gradle has a public repository API, there's no clean way to to consume P2 artifacts inside of Gradle. And if you want, there's a thread where they're discussing it. Luckily, there are workarounds. So workaround A, the first one, is to turn a P2 repository into a Maven repository. And this was pioneered by Andre, I might not say his name right, Andre Hilovsky's plugins. One's called Woof and one's called Unpuzzle. And huge credit to Andre. He really broke ground in building the first plugins that made Eclipse development work in the Gradle ecosystem. That said, so we use Woof and Unpuzzle originally. They're pretty monolithic, so you tend to get the whole kitchen sink when you use them. And they also don't support full P2, so They can't download from a composite repository. It can, any P2 repository in general, you need to download a zip file of a bunch of jars. So you can't get the latest and greatest Eclipse versions that way. So once he's downloaded these jars from P2, he captures some of the dependency information using require bundle headers. Simon Templar has a fork of Unpuzzle, which also looks at import and export package headers to reconstruct the dependencies after the fact inside of the Maven dependencies. So the problem with that, like I said earlier, is this multiple version problem. So you can't map that into Maven very well. But those are approaches. Another approach is to make a P2 repository look like an Ivy repository using some URL formatting tricks. This is what Gradle's buildscript uses right now, so you can look at the source code for buildscript for an example of that in action. The big downside to that is you have to manually specify every single version that you want. And Eclipse versions are usually pretty long. They always have the date qualifier, so that's really tedious and pretty error prone. So the approach we recommend is a Goof plugin we've developed called p2.as-maven. And the way it works is you specify the P2 repositories you want to download from and the units and features you'd like to get. And it downloads those and all of their dependencies and stuffs them into a Maven repository. And we don't encode any dependency information inside of that Maven repository. We just dump it in raw. And we might add flags for that functionality in the future. The problem is we have found that in practice, the Maven flattening things always require some hand fiddling. So if you're going to have to do hand fiddling anyway, you might as well just do a lot of hand fiddling. And the dependencies don't change often. So once you've set up your transitives, then they'll be stable for a long time. And as the versions change, the plugin handles that automatically. So you don't have to type versions automatically. You don't have to type versions by hand. The next thing you need to do if you want to build an Eclipse plugin is you need to generate OSGi metadata for your jar. And for sure, the way to go in this space is to use the Bund tool developed by Peter Kreens. So the way that Bund works is you give Bund your jar and some directives, and it calculates the headers for you automatically. There are a lot of Gradle plugins that integrate with Bund out there. But we've tried a lot of them, they all had their own little quirks that we had issues with. So we've developed our own called OSGi.bundmanifest, and it looks like this. The difference between this plugin and the other plugins in the marketplace, or the, what's it called, plugins repository, whatever the directory of plugins is. The difference is, number one, this plugin copies the manifest into your source tree where the IDE can see it. And so the jar that you've built and the manifest in your source tree always match. So with a lot of other plugins, we'd have a problem that the jar in our build was different than the jar we could see in our source tree. It would be like one build old kind of problems. The other problem is a lot of the OSGi plugins, including the one I think built into Gradle, does a manifest merging. So that means that you have these Bund directives where you're telling Bund, I want you to generate these headers, and then those are merged with other existing headers already in the existing manifest. And the problem with that is we've had a couple times these loops where on each build something gets added and added and added. And you've got two sources of truth. Some of your manifest comes from the manifest, and some of it comes from your build file. So this plugin can do merging if you want, but by default, the manifest that is generated is a pure function of these inputs here. So it's very repeatable, very simple. So now that you can get things out of P2, you can make OSGi metadata for the jars that you're building. The next problem you're going to have is you're going to want to consume dependencies from Maven. And those dependencies might not have OSGi metadata. And you need OSGi metadata if you're going to use those dependencies in an Eclipse application or a plugin. So luckily, Simon Templar has this plugin called Bund-Platform, which is perfect. It does exactly what you need. What it does is it loops through all the dependencies and transitive dependencies in your projects and just copy paste them into a folder. And if they have OSGi metadata already, it just puts them in raw. And if they're missing OSGi metadata, then it uses Bund to generate that metadata automatically. And it's got really good defaults, and it generates very sensible metadata. If there's a plugin that needs special handling, even if it already has OSGi metadata and you need to change it, it's got a great DSL for handling those corner cases really elegantly and just making it really concise to wrap up all the OSGi threads. So the final step, if you're going to build an Eclipse RCP application, is you're going to use something called PDE Build to build your native launchers and tie all your plugins together into a coherent feature or product. So the way that we do this is by shelling out to an Eclipse instance, which has this little headless application inside it that you can call. So the kind of magic under the hood of GUMF and all these plugins we've been talking about is that we have what's called the P2 director application, which is one of these headless Eclipse applications. It has this P2 director application embedded inside it. So that means we can download and install an Eclipse IDE with any set of features. And we can use this bundle pooling feature we talked about at the very beginning, where an instantiation of PDE Build takes very little memory. So what it looks like in use is you specify the version of PDE Build you want to use. If you're using an official release, you can just use 4.5.2 or 4.6.0, whatever the official version is. And if you have your own custom patches, or if you want to use some kind of nightly or snapshot, then you can manually specify the update site. If you've ever used PDE Build, you know that there are a lot of properties. There's this build.properties file that you have to set a ton of things in, and there's a lot of mutually exclusive arguments, and it's kind of hard to get your head around, or we had a hard time getting our head around it. So we've wrapped that in a Gradle DSL, so it's pretty concise to build the thing that you want to build. So now we'll kind of recap tying all these plugins together. So if you're going to build an Eclipse RCP application, so these are all the plugins in our RCP application that we'd like to build. So for each of these plugins, we would recommend using this OSGi.bundmanifest plugin, which generates the OSGi manifest and metadata. Then the Eclipse.build properties plugin. What this plugin does, so Eclipse, especially when using the PDE, the plugin development environment, it uses the build.properties file to control the build within Eclipse. And what this plugin does is it makes Gradle also use the build.properties file to control its build. So it means that the Eclipse IDE and your Gradle build file are always in sync because of this plugin. The next plugin is Eclipse.exclude build folder. So inside of when you're using Eclipse, if you do Control-Shift-R, you get to open up the Resource Explorer. It's like the fuzzy search, fast search kind of thing. It will index the Gradle build folder by default, so that it will include all the class files and garbage that Gradle makes. And so it slows down the search, and you're not actually looking for any of those things. So this plugin just excludes those from the Eclipse search path. The next plugin is Eclipse.project deps. So if you have a lot of intra-project Eclipse dependencies, we've had intermittent problems where the projects that Gradle builds don't work. They don't link the projects correctly. We never quite understood why they didn't work, but this plugin fixes them. So if it ain't broke, don't fix it. So if we're going to build all these plugins into an RCP application, then we're going to have to make our target platform, so the universe of plugins that we compile these against to make the final application. So the way we recommend doing that is to have two folders, one called target.fromMaven. And so this is the one we just talked about, which creates a folder containing all of the Maven dependencies along with their OSGi headers. The next step is to have a folder called target.fromP2. So this creates a folder which has all the dependencies from P2 and then gives Gradle access to those artifacts. So we have a dedicated folder for things from Maven and a dedicated folder for things from P2. And then lastly, we have this deploy folder, which runs PDE Build against both of these target folders as well as all of the plugins. Real quick, I want to show you a sample of all this working. So I can't remember the URL, but if you go to diffplug.com/open source, so here's the repository with this sample project that builds an Eclipse RCP application it does all the download from P2, download from Maven, build the final native launchers. And you can also on GitHub, Gradle/Goomph. This is the plugin that's doing a lot of the work, and it's got pretty good Java doc usage examples, so it should be pretty easy for you to adopt. So lastly, the last thing I want to talk about, and we are, the last thing I want to talk about is generating your IDE as a build artifact. So the advantage of creating your IDE as a build artifact is that it makes it really easy to onboard contributors and make sure that they're set up with the white space settings you want and the tabs for spaces and if there's any annotation processor code generators you're using, things like that. You can make sure that all of those are set up and working right off the bat. The other thing is, I don't know about you, but I'm always a little scared when I get an IDE just right. I'm always scared to install a new plugin because sometimes that'll muck up the dependencies of other ones and it won't work, and then I'll install it and then nothing works and I have to start all over. So what's great about this is because you can generate your IDE deterministically, repeatedly over and over, you can always try, just like, well, I'll stick this plugin in, and if it works, then we'll add it to the build forever. If it doesn't work, then we can go back to the previous state instantly, no problem. So the disadvantage is that the Eclipse is a big application. It takes like 200 megabytes. But as we've discussed earlier, that's actually not a problem because of bundle pooling. So all the jars underlying the IDE will be installed in one central location in a cache folder, and it's just this little 1 megabyte that shows up to run the IDE that you've asked it for. So what this looks like in the DSL, so similar to what we keep seeing, we have this model of the P2 artifacts that we want. You add the repository, you add the features that you want. If you're just building a regular jar, then you're done. That's all you need. If you're building an Eclipse plugin or product, then you have this target platform thing where you'll need to specify the universe of plugins to compile against, and so you can specify them here. So the underlying this is a separate, so our plugin is called Goomph with a G. At Eclipse, there is a project called Oomph without a G, and they've built a ton of tooling for automating the provisioning and setup of Eclipse IDEs. And right now, we don't leverage that at all. We've got a totally separate line that is much less capable than what the full Oomph can do. But we're working on it. Hopefully we'll be able to combine our efforts so that we can, everything you can do in Oomph, you'll be able to do in Goomph, and you'll be able to have your whole IDE set up and encoded right there inside of your build file. So that's the talk. Any questions? No questions. Okay, well, so the main audience for this talk was Eclipse developers who aren't using Gradle yet. So it's not that surprising that they're not here at Gradle Summit. But for any Eclipse developers who end up seeing this on the internet, I'm on Twitter at Ned Twigg. Let me know. I'd love to work with you to build this stuff and make it better. Thanks a lot for your time.